Welcome to Inside Tech, a podcast by MediaTek. Here, you'll get the inside scoop on the latest trends, developments, and technical deep dives across embedded and consumer tech. In this episode, Adam King, MediaTek's VP and General Manager of Personal Devices, speaks with Francis Sideco, Principal Analyst at TIRIAS Research. They talk about how MediaTek is scaling edge AI across a diverse range of devices and markets. They cover what's next for physical AI, the hype around AGI, and MediaTek's partnerships with NVIDIA and Google.
Adam, good to see you and talk to you.
Good to see you, Francis. How are you?
Good. What we want to talk about today was MediaTek's, huge portfolio and presence across really multiple markets, but also specifically around what you guys are doing with AI. MediaTek, I don't know if everybody really knows how diversified you guys are with the wide range of markets that you meet. Could you maybe familiarize everybody that's listening on maybe the breadth of your product portfolio and market reach across all the different verticals out there?
Sure. Yeah, you're right, Francis. We are in a really wide range of markets and products. We are in 2 billion devices that ship every year across a whole bunch of markets: Chromebooks, tablets, smart home devices, routers, and now increasingly vehicles, data centers, and some other growth areas. And of course, smartphones. You probably have several MediaTek powered devices in your house right now.
Yeah, absolutely. And I think what a lot of people might not appreciate is each of those markets that you mentioned have very diverse and often conflicting requirements on a chipset supplier such as yourself. So it's pretty impressive that you guys have been able to meet all of those, all of the needs of those different markets. I think clearly AI is a big factor in that. And I kind of want to explore AI in a couple different ways because it's central to obviously providing that capability to those markets, but potentially too within your own product development. Is AI helping you guys at all in being able to address all of the diverse needs of all those different markets?
Yeah, absolutely. We've been in AI for several years, really as a way to improve the performance and power efficiency of our devices. And so we are, I think, now on our 8th generation of our AI accelerators that we use in our consumer devices. So we've got a lot of history here on building AI for certainly for traditional applications like image recognition, image quality enhancement, voice recognition, and so on. And now with generative AI, that's just another order of magnitude in the opportunity and some changes in the architecture that's required to really be optimal for that. But I would say our AI is probably in the majority of chips that we ship. And in certain segments, we're top to bottom.
And speaking of that, I know you guys have developed your own NPU, and I think you're using some GPU IP from NVIDIA. Can you talk a little bit how you guys are leveraging those assets, both as MediaTek, but potentially even in partnership with NVIDIA if you are, and maybe what segments you guys are focusing on with that collaboration?
We view the partnership with NVIDIA and their GPU for AI as very complementary to our overall product portfolio. So our NPUs are designed for extremely power efficient, high performance AI processing at the edge. Just as an example, we have NPUs that run at 100 TOPS in a smartphone. But there's applications that require more performance, especially visual workloads where a GPU is more appropriate, or where developers want to run the same models that they're running in the cloud. So our partnership with NVIDIA is bringing AI and high performance capabilities to things like the GB10 chip in the DGX Spark that's been announced in the automotive space and potentially elsewhere.
Yeah, so it's interesting you mentioned DGX with workstations, but also automotive. Do you think there are other segments that you might be able to leverage this capability on, especially as we start getting to maybe even physical AI, right? Where it seems like there's a lot of commonality between what automotive needs are to what physical AI applications might need.
Yeah, I totally agree. I mean, I think autonomous vehicles are probably the biggest example of physical AI, where
Absolutely.
when you have products that interact in the real world and need absolutely real time response and inference, you need very high performance edge AI. And autonomous vehicles is certainly a huge opportunity that we're pursuing. But you could see it in robotics, especially humanoid robots, and other applications as well. Even augmented reality glasses are kind of a big step towards physical AI, because these devices need to work in the real world as you're walking around a city or something, and you're trying to overlay digital information. You need that real time performance and AI.
Absolutely. And clearly the MPU that you guys have developed is pretty scalable. I mean, just based on the applications and use cases that we've just been talking about. What is it about how you guys designed that NPU that's allowing you to be able to scale from something that's relatively simple from an AI standpoint all the way up to what we were just talking about with the needs that physical AI would need?
The scalability really comes from an architecture that in a way is a lot like CPUs and GPUs in terms of having a number of scalable cores. So our NPU cores can scale with the application. If it's a small mobile battery powered device, we can have fewer cores, and then we can really scale that up into even much more than we're doing today. The challenge on the scalability really becomes about memory bandwidth more than the NPU itself.
Yeah, and when you say memory bandwidth, do you mean in terms of the I/O that is going in and out of NPU, or is it the actual maybe the capacity of the memory that the NPU can interact with? Maybe give a little bit more into that.
Yeah, it's less about the capacity and more just about the raw amount of data that you can process per second in and out of the NPU. If you want, the very highest, the biggest models, the highest quality, the most token rates, time to first token, all of these different ways of measuring AI, you need lots and lots of memory bandwidth.
Yeah, it's kind of funny as AI continues to mature and we start to really understand what it takes to make it work. I mean, clearly the processing capabilities, whether it's on the CPU, GPU, or NPU, you have to have that. But it very quickly becomes a data movement problem as opposed to anything else. And memory is definitely critical in that.
Yeah, and certainly, not to undersell the NPU, there's a lot of features and capabilities and new data types that we support with each generation. So the efficiency and the capability of the hardware is definitely increasing at a very fast rate gen to gen.
And with that increase and with that, the scalability that we've been talking about, I think what maybe the other aspect that may be kind of underappreciated, undersold is the software development part of it. Because AI is such, the developer community is so important when it comes to taking advantage of this. And I know you guys have developed your NeuroPilot SDK. And it's got some really cool capabilities in terms of allowing these developers to maybe write once and then apply everywhere. Can you provide some examples of that in action? Maybe some of the tools, the library resources that are available that helps provide that? Because it's both a scalability thing when you're going up and down tiers of products, but it's also a scalability thing when you're maybe able to reuse as a developer a solution that you had and then tailor it to another segment that maybe just needs a little bit of a tweak, but you can leverage that. So that helps with the scalability as well.
Yeah, for sure. I mean, you touched on a couple of important things there, and the first of all is that software is important, and yeah, maybe underappreciated when you read articles comparing hardware-based benchmarks. It's sometimes the software story gets a little bit lost, but without a full suite of software tools, the hardware is not useful. So we do have our NeuroPilot suite of tools and APIs to help developers build their applications and take advantage of all our hardware capabilities. We support all of the frameworks like TensorFlow and PyTorch. So I think we make it pretty easy for our customers to be able to take advantage of the silicon. But you make another excellent point about having that scalability across different devices. If you run your applications on phones and tablets, and other devices like wearables and smart home devices, it's great for customers who participate in multiple segments to just be able to reuse their investment across those product categories.
Yeah, and part of that for you guys too with NeuroPilot is you actually extend even further. We talked about the high end, we talked about the spectrum, but you guys even extend further into where you guys have a NeuroPilot Micro for TinyML as it gets deeper into that. Where would you draw the line, and what metric do you guys typically use where you say, okay, you know what, this is kind of the boundary, we should probably start using NeuroPilot Micro versus just regular NeuroPilot?
Yeah, there's a lot of applications that need machine learning, but don't need a ton of performance. Applications where power is really the predominant thing to solve for. So things like sensors, microcontrollers. A good example is a low power computer vision sensor that is in an always on mode and trying to detect changes in the environment. That has to run at milliwatts. And so we have NeuroPilot Micro as a version of our tool to handle those tasks. And along with that, we have a tiny eNPU, an NPU, or we call it an eNPU for such applications. So it's just maybe a good example of how we cover the spectrum from milliwatts to gigawatts.
It's actually interesting you say that, and the fact that you guys have architected it in that way, because we're talking about physical AI, right? Or even some of the more advanced uses of AI where you potentially could have an environment or an application where you actually need both types, a milliwatt type of AI or ML and the more powerful models. Like, for example, like in a physical AI situation, you might need some machine learning kind of at the where the hands of the robot are. And it might need to then interact with, or maybe even the sensors, right? Anything that it's using to drive the sensors for how it's understanding its physical environment, and then interacting with that internally to the higher processing needs of, okay, what to do with that stimuli. So do you see, or did you guys architect NeuroPilot and NeuroPilot Micro to be able to kind of work together in a complex system such as that?
Yeah, absolutely. And you're right. There's a lot of devices and usages where it's not either or, but it's like a staged process where you use the eNPU to detect and wake up the system. And then, your algorithms decide, do I now wake up the big NPU and the big CPU to respond or carry out a task? It's really all about optimizing power. You don't want to wake up the big processors every time there's an event when you can do it much more efficiently with the tiny versions.
Now, for those that are in the developer community, maybe that one question that they always have is how often are these tools updated? What's the normal cadence for you guys?
Oh, that's a great question, Francis. I don't know the schedule, but I can tell you that we regularly update the tools where we're adding new features, optimizations, model support, framework support. So it's current.
Yeah, I mean, just because you mentioned earlier, the pace of innovation and evolution in this area is so rapid. That's always kind of a question that we hear when we talk to the developer community with respect to these tools. So that's good to hear. So maybe switching gears a little bit, like we mentioned how broad of a reach you guys have. And when you have scale like that, oftentimes you become a very interesting partner to other companies. Can you talk a little bit about some of the partnerships? We talked about NVIDIA, but you guys obviously also have a partnership with Google. Can you talk a little bit about some of your other partnerships and how you guys are looking to leverage those?
Sure. Google's a great example. Last year, we worked with Google and Lenovo and Acer to bring out Chromebooks that use our higher end Companion Ultra that has 50 TOPS of onboard AI performance. And that enabled Google to bring a portion of their AI models on device. So it's very cool. I mean, it's in the market now. It's been in the market for several months. Great devices that use local or edge AI to do things like smart grouping of all your tabs, image editing to erase items, and just deliver a better user experience on a number of fronts. That's been an exciting collaboration, and we hope to extend that to other devices as well.
So as you get into those kinds of devices and double clicking a little bit on some of the conversations we've had, we've talked about the fact that a lot of times in these AI applications, it's not a standalone thing, right? And obviously within your guys' framework and your environment, clearly everything is able to work together. But as it continues to expand, from what we can see at TIRIAS Research, that there continues to be an expansion of what we're calling collaborative AI or multi-agent AI, swarm AI, whatever you want to term it, where models more and more need to be able to work with other models, whether it's within the same family or the same manufacturer or third party. How are you guys thinking about that whole dynamic?
I think that the foundation of it is that we support the industry standard frameworks and compilers so that developers have the freedom to move their models onto our hardware. We also offer, we talked a lot about the NPU, and the NPU is critical to some AI workloads. But there's some things that run better on the CPU, some things that run better on the GPU. And there isn't a simple formula for figuring that out. It really comes down to the specific device and the use cases and how the developer or the OEM wants to optimize. So providing that support and flexibility, I think, is one of the things that differentiates us.
So here's a little bit of a question that I'd like to ask everybody I talk to, especially around this area. AGI, do you think we'll get there? Or do you think it's still pretty far out?
I tend to be in the camp of I think it's further out than some people would have it. I just, these tools and these capabilities are absolutely amazing. They're like magic, but you also can pretty quickly see the limitations of them. When you think about the progression from generative AI to agentic AI, it's a totally different ballgame, right? It's agentic AI in some ways is a lot harder than generative because, you're not just asking a big model a question. You're having to put together inputs from multiple different data sources. The industry needs to collaborate on having standardized interfaces for those different data sources. And then the AI moving from responding to a question to being proactive, we're just getting started on that. One of the challenges for AI is having a big enough context window to remember everything. And so there's a lot of techniques that are being developed on memory hierarchies to, store and retrieve information and figure out how to bring it back when it's relevant. When you think about a human who's been around for decades, they have a context window that's 50 years long. It's going to be a long time before the AI replicates that. And that's really the source of human wisdom and experience. So maybe it'll happen a lot faster than I think, but my gut is it's actually a ways off.
Absolutely. Yeah. And it brings up a lot of other questions too, other than just the technical stuff. But we won't go there because we only have a few more minutes left. Adam, any last minute thoughts on? I mean, we've covered a pretty wide gamut of MediaTek's capabilities, the markets that you guys cover, the solutions that you have on there, and obviously you guys aren't staying put, right? You're continuing to develop and innovate. Any thoughts on any other things you want to make sure we capture or talk about, or maybe some thoughts on where you guys go from here?
Sure. I think one of the questions that I get, or that the industry has a lot, is how much of AI lives in the data center versus on device, and what will it look like in the future? And that's a very important question for us because we participate in the cloud and the edge, but especially edge devices is where we come from. And I think the answer, we don't know the answer, right? Things could change rapidly, but certainly today we're seeing most of the AI being processed in the cloud. And I think maybe the majority will likely stay there because you can support massive models and you have gigawatt data centers that just have several orders of magnitude of performance more than any edge device could offer. But there are a lot of and growing use cases where it makes sense to process at least some portion of that workload on the edge. We talked about physical AI, where you have to be absolutely real time. If you're in an autonomous vehicle, you can't wait for the packets to go back to the data center and back. It's got to be processed real time. So as physical AI grows, we see more and more of the processing move to the edge. And even in existing devices like tablets and phones and PCs, we see growing numbers of applications running at the edge, and we can measure the user experience, and it's notably better. If you use the latest Samsung tablet, they've put a lot of AI models onto the edge, and the snappiness and the responsiveness and the ability to work offline is really noticeable as a user.
Yeah, I think absolutely. I think, as AI continues to proliferate into every aspect of what we do, there's going to be, I think you've alluded to this throughout this whole conversation, is there's going to be a best tool for the job. And we have to use every single tool available to us because it's just too pervasive to try to do it monolithically or in one way or another.
Right.
Adam, thanks for spending some time with me. That has been extremely insightful into MediaTek's capabilities, but also how you guys are seeing the AI area evolving. And it's a pretty exciting time right now for us.
It's a busy time, but it's really, really inspiring to be in this space right now.
Perfect. Thanks, Adam.
All right. Thanks, Francis.